It's our chapter. Name of this lecture is in front of you. Sound. In details, I will explain with you about it. You can think that we are in group. Okay, we are discussing it together. Some questions I will take from your side regarding this lecture. We will have to accept some questions of this lecture. Then it will be interesting. Then it will be understandable. Okay, we will be able to understand logically, practically. Okay, when we will ask and answer, then it will happen. Name of this lecture is what? Sound. Yes, in details. In details, I am telling you. We are going to explore it. Its property will be discussed, will be covered in this slide. From meaning of it till the types of a sound and more. Apart from this, will be covered in this slide. Now we are moving towards the next slide. What is a sound? From simple meaning of a sound we are starting. It is asking you what will be meaning of a sound. Yeah, in your language, meaning of this could be something. In book language, meaning of this could be something else. But sense, meaning should be same. At least it should be same. Meaning should be same. Explanation of sound can be different, but meaning should be same. Okay. In our language, in human language, we can explain like this. We would say sound. We hear different sound of a human, sound of a man, sound of a woman. All this a type of a sound. Even right now, I am hearing sound of somebody is coming. Somebody is doing his work, and that sound I am hearing. So okay, all this, when fan moves, then we are able to hear sound in our daily life. We cannot ignore it. Whatever sound is coming cannot be ignored. So I am saying what, in our daily life we hear a lot of voice, even different voice. Voice of a man would be what, heavy, more different. Uh, Voice of a man is a different from voice of a what, woman. Is it true? Yes, it is a true. Okay, so here question arise: what's the reason behind coming a sound? Okay, how is a sound coming? What's the reason? And you can say this is a question. Sound is coming, so how is it coming? This is question. Can some of you explain it? Okay, we now that we hear a lot of voice, a lot of even voice of animals, voice of insects, voice of humans, voice of vehicles, voice of non-living materials, voice of living materials. We hear when we even when we take what two material, then we hit mm, both materials together, then we produce what? We produce a sound by using this two material. Then sound comes out. So here question is how it came. How did it come? This is question. It seems magic, isn't it? It seems magic. You would say, wow, it is magic. But behind is there is an explanation. After understanding explanation of a coming sound, you will say yes, it is it is the reason behind coming sound. So answer is what? Uh, Vibration. Yes, vibration. When objects when objects produce a vibration, then at the same time voice comes out. So voice comes out when vibration happens then. Clear? So how will vibration happen? When two or more objects will hit to each other, then only one object cannot produce a sound. It will be impossible until another object will be hit will be hit on the first object. Okay. uh, you can observe it wherever whenever you are observing that, oh, yes, voice is coming from there, then just observe carefully. Observe that sound is coming. So sir was saying that it is coming because of vibration, and vibration happens because when two objects are hit to each other. So so is this happening there? You will have to observe carefully, then you can observe, yes, it is happening or not. You will observe that, yes, object one object is being used to another object, then voice that's why voice is coming. Otherwise way of producing of a vibration can be something else, not the same. Way of producing vibration can be different. Remember. Okay. Remember, I am telling you. Clear? For example, I have two hands and I will hit like this. Then little sound you can listen. So it happened. Here vibration like this. Yes, it is invisible. We cannot see directly. It is vibration is invisible. Okay, it is a way you can say. But the sound is also invisible. But we can feel. Okay, so here I am telling what, until we will take two objects or more, then voice will not be produced. So here I have two objects, that's why you can hear voice. And here vibration happened. Yes, I know it is hard to feel that how did a vibration happen. But don't worry, gradually you will understand. Something you will notice to understand what to understand vibration happening. How is vibration happening? How does vibration happens? You will observe slowly, slowly. So here in book language, what is the meaning of a sound? Sound is a form of energy produced by vibration. Yes, it is a form of energy. and it is produced, sound is produced by vibration. Wherever sound is coming, so at that place vibration will be happening. Vibration happened, that's why sound came. Clear? So it is telling you, when vibration will come, then sound will come. Travels in the form of waves through a medium. Yes, yes. In vibration you can observe what wave of a sound. Okay, it travels in the form of waves. It means it will hit. Now here you can observe what vibration. Vibration, which means it is a wave, and it travels in the air, and it hit to particles. That's why we listen, we hear what voice. Clear? Pitch, frequency, uh, loudness can be different. We will talk about it. So remember, it travels in the form of waves through a medium. It needs to vibrate. It needs what medium, like air, water, solids. From this, you understand what three types of materials you should have. You should have three types of materials, and in these materials, sound will travel. Clear? These are mediums which are solid material, liquid material, air material. All this type of materials in this uh, sound will travel. Clear? Cannot travel through a vacuum. Clear? Understand clear. Vacuum, which means vacuum, vacuum, empty. Meaning of a vacuum is empty. When there is a nothing, okay, there is a nothing. Even in a sky, even in a sky is what air, particles of air. We cannot say that a sky in a sky is a vacuum. No, no. In a sky is particles of air. So it is a telling it will travel when you will if you have either solid material or liquid material or gas material, but you have nothing, it means area is vacuum. So remember, area is empty, then sound will not travel. Sound will not travel at all. Clear? Let's move ahead of this slide. Now, with question, we have a discussion in this slide. How sound is produced? As we saw, it will be produced by vibration. So, how will vibration be produced? When two objects will be used. When two objects will be used and two objects will be hit to each other, then vibration will come. Now, by using two objects, vibration is coming. So, of course, if a vibration is coming, then it means sound will come. That's it. So, sound is produced when an object vibrates. Yeah, vibrates, which means when a object will be hit on another object, then vibration will come. Okay, that's all. We have examples like guitar, string, tuning form. In front of you, there are two figures. First is first figure of four guitars. Second is what? Vibrating air molecules. So this is an example in which vibration can be observed. Here we play a guitar, and when we play guitar then voice comes out. So how does it come? Hold on, I would like to show something. It is not working. So here this is our eyes and this is our ear, and here this is object. Let's say this is object. Here a object is being hit on this object, then in air particles are disturbed. Particles are disturbed when when a object was hit on this object, on another object, then particles are disturbed, and it is a traveling. This vibration is a traveling, and it is reaching to our ear, and that is how voice reaches to our ear, to our ear. Clear? So remember, what is the process of coming sound? In this figure you can observe what a vibration, you can observe coming sound. So what is the process of coming sound? when a when a object when an object is hit on another object, then it produce what? Vibration. Now it will travel in air, as you can see here. One Some particles will disturb to another particles, then this particles will disturb to another particles, then another, like that. So all these particles are disturbing. Why? How it happened? Because of a object was hit on another object, that's why particles were uh, distracted, you can say, were disturbed, and that is how it will travel to, and it will come to our ear. Then we hear that yes, this is voice of this. Clear? Vibration make surrounding air particles vibrate and carry the sound forward. Yes, it is coming like this. What sound is coming like this. Clear? In this figure, what is happening here? Vibrating air molecules. Vibrating object. Yes, this is object. Object was hit on this object. Then here it disturbed particles. Then here particles came into motion. Some particles disturbed to another particle. Then it disturbed to another particles, and that is how sound traveled to reach our ear. This is the process of coming sound to our ear. Let's move. Propagation of a sound. Propagation of a sound. I know it will be new for you, but it is not completely new for you. There is a connection of a propagation of a sound with the previous discussion. Propagation of a sound, it is like a wave, and it is a wave. Okay, it is a wave, but it will tell you something different discussion. It needs a medium, and medium can be what? Objects, and objects can be solid, liquid, and gas. Okay, for example, I have this earbud. So this is a solid material. I will not go in details about the solid liquid material. So solid has a what shape? Yes, it has a shape. Solid can be this earbud, solid can be mobile device, liquid like water, juice, gas like air, particles, all these are gas. Okay. So these are objects where sound will travel. And here it is saying uh, propagation of a sound needs a medium, and medium can be object. It travels faster in solids, slower in liquids, and slowest in gases. It will be useful to you. Understand here. Always remember, if we have what? If we have solid material, then it will travel faster. Let's just say sound is coming from there, and we have object here. It will come like this, and then it will hit, then turn into another direction. So a speed of this will be same or fast. Clear? If a sound is being produced in liquid material, then what will happen? A speed of sound of coming sound will be slow, will be slow, not more slow, but at a middle level, at a middle level. Now, when it comes to what about air, so I would like to say it is a true, even I observed, and you would have observed when thunder, lightning, we observe, then we see what light came. First of all, light will come, lightning will come. Then after few seconds, what uh, sound we hear of lightning when weather is what not well then it happens. Sound came late. Why? After few seconds. Why? Because of it traveled in air. That's why it travels in air. That's why it comes late. It is happening in a nature, which tells us truth that yes, it will happen. It is the reason behind of happening this phenomenon. Clear? So always remember, uh, in solid material, a speed of sound will be faster, but in liquid material it will be slow, but in gas material it will be more slow. Now, no propagation in vacuum. Yes, we saw a space is a silent. Okay. So always remember, as we saw that vibration will not happen in vacuum area, then it is the same. It is the same for propagation of a sound. No propagation will not happen in vacuum area. Let's move ahead. Characteristics of a sound. We will observe this, and it will be useful in the numericals of this lecture. Uh, Before we move on numericals, you will have to understand what is the meaning of amplitude, frequency, time period, wavelength. When you will have meaning understanding of regarding this characteristic of sound. Then you will think critically, you will think logically. Answer came why you will answer. So here characteristics of a sound we are going to understand in this slide. Let's start from amplitude. It determines what loudness in graph of a sound of wavelength of wave. We will observe what amplitude. What is amplitude? Here I can say what without the graph I can say that amplitude is a height, but no, it is just a theory. It is just a theory. Where is the practical? Here this is a experiment. This is a practical. So it is telling you if amplitude would be high, then what will be uh, nature of a loudness. So nature of loudness will be determined by amplitude of a wave. Frequency will determine pitch. Pitch is high, pitch is low. So who will determine? Who will decide? Frequency of wave. Time period. From time you can say that yes, it will tell time. But when it comes to understanding, then what would you like to say? So remember, always remember, uh, in this lecture, in this slide, meaning of a time period is what? Within one one wavelength passed within within how much time? Within how much time a wavelength passed, and that time will be taken in formal in numerical system. So time taken for one vibration. It means one wavelength will pass. It means one vibration will happen. Wavelength and distance between two compressions or rarefactions. In graph, you will see what wave crust, wave tuff, and here distance between two wave crust will be one wavelength. Between distance between two wave tuff will be wavelength. Clear? Will be wavelength. So always remember, amplitude will say that this is a loudness. Frequency will determine pitch is high or low. Time period will tell you within how much time uh, one wavelength passed. Passed is what distance between two compressions or rarefactions. Yes, compression. What is a compression? What is a rarefaction? So here you can see this area. This area is telling you it is here particles are more, and this area is telling you particles are less. I am not telling you. I am not saying that here particles are nothing here. No, here are particles, but amount of particles here are less, and here amount of particles here is more. So from this you understand meaning of a compression and rarefaction. So this area where particles are more will be named as a compression. Area where particles will be less, then that this area will be considered as a rarefaction. Clear? Clear? So yeah, rarefaction, compression. Okay, that's it. So here what is happening? Compression, rarefaction. Okay, cool. So shall we move towards the next slide? Let's Audible and inaudible sound. Yes, it will be also truth. Even nobody knows what about it. Audible and inaudible sounds. Amount of sound that we hear will be what will be fixed. Will be fixed. If you hear voice more than amount of this 20,000 hertz, then your ear will damage. Clear? If you hear amount of less than amount which is less than 20 hertz, then you cannot hear anything. But yes, your ear will not damage. Your ear will damage when you will hear more amount more than 20,000 hertz then. And remember, between 20 hertz uh, to 20,000 hertz, it is a audible range for each person, for each human. Between 20 hertz, from 20 hertz till the 20,000 hertz. This is amount of voice in hertz. And if you are hearing uh, this much voice, it means you will be able to hear voice of anything which amount is between 20 hertz and 20,000 hertz. Infrasonic. Infrasonic, it is what? It is the explanation of if voice amount of voice is less than 20 hertz, so that voice will be considered as infrasonic, below 20 hertz. And this much hertz, who will listen, who will hear? Elephants. Animals, you can say elephants. And above the 20,000 hertz will be considered as ultrasonic. And this above this hertz, who will hear? Bats, dolphins. This will hear. Here in this figure you can see, from here to till here is what? This is the amount of hertz of voice, which is between 20 hertz and 20,000 hertz. And this is for human, and this is for animals, this is for insects as well as dolphins. Okay, it is ultrasound is a amount of voice in hertz which is more than 20,000 hertz. That's how you will explain. Okay, infrasound is a amount of voice which is less than 20 hertz. Okay, it is for animal. Hmm. I am moving towards this slide. What is this? This is figure of vocal cord, which is found in human. Here. Vocal cord is here of a human. Why are we? Why are we? Why do we have this? Why are we understanding this vocal cord? Reason is simple. It is a place. It is a something by which sound is produced in human, here in a neck. Yes. Where does vibration happen in human? Even we speak, here we hear voice of man, women, children. So a person is a one object. So what about another object? How how is voice coming without another object? So answer is here vocal cord is found in human where sound is produced when we speak. Then vibration happens in vocal, and then we hear voice of a man, voice of a woman. So vibration happens in vocal cord. This is what I am trying to explain. So sound produced by humans. Human sound is produced by the vocal cords. Vocal cords. It is a vocal cord. Vocal cords vibrate when air passes through. When air will pass, then it will vibrate. Tensions and length of the cords affect the pitch and loudness. Yes, when you will take tension, then there will be effect of a pitch and loudness. Your voice will be something else. Okay. So from this slide we understood how does a human produce a sound. So we saw that sound is produced by human uh, because of because of vocal cords, and vocal cords is found in human where sound comes where sound comes after happening vibration. Clear? Next, a reflection of a sound. What about this reflection of a sound? uh, Even I explained what the reflection of light. Explanation of a reflection of light will be same in this, but slightly will be different. Let's understand. It is telling you when, as we saw that sound travels, but direction of a sound will not be always in a state. Okay, will not be always in a state. Direction of a sound can be different. Remember, that's why I'm telling you something will be difference from the discussion of reflection of light and in this. It travels we know. Remember, when it comes to reflection of a sound, it means light will travel after, no, sound will travel happening, after happened vibration. Then sound will travel. When sound will travel, so first sound which came from after happening vibration, that sound until it hit on another object, so that sound will be considered as incidence sound. But when it incidence sound will hit on another object, and then it turn into another direction, then this sound will be considered as a reflected sound. Clear? Same, same. It will turn into another direction. Clear? Sound reflects of hard surfaces. Echo. Surface should be hard. Then you will observe echo. Echo, which means a reflected sound. After hitting a sound, when it will hit when it will hit on the surface, and then it turns, so this one turn of a sound of incidence sound will be what? Echo will be, it is what? A reflected sound. And this one reflected sound will be echo. One I'm telling. Now, what is the meaning of echo? Meaning of echo is you will you will hear what your same voice. You will hear your same voice. So after 0.1 seconds, you can hear your voice clear. Echo can you can say echo. You can hear echo after 0.1 seconds. Here you can say echo heard when sound reflects back after 0.1 second or more. Used in sonars, stethoscope, auditorium design. It is used in medical. It is used by doctors. Here you can see this person is vibrating. This person is using two objects to vibrate, and when this person will use two objects, then come, sound will come out. Then it will hit on this surface. Then it will turn into another direction. This turning sound will be echo. This person will listen this reflected sound after 0.1 second. This is what this slide is not this is this sentence is trying to tell you. Clear? So echo is what? Echo is the first reflected ray, not second. What about this? This is a surface area. You can see this is a person, and here this is a watch. Uh, Alarm is a fixed after time is completed. Then it this watch will produce a sound. So some sound will of this will hit on the subject, then it will turn into some uh, voice of this sound of this watch will turn into this direction, and that is how this sound will reach to this person. It will listen, it will hear, it will awake, he will awake. So that is how sound reaches to our ear. Clear? That is how uh, a reflection of a sound happens. Clear? So how does a reflection of a sound happen? It vibrates, then will hit on another object, so it will turn into another action. So turning of what sound is a reflection of a sound. Let's see next slide. Musical and noise. Noise is what? Noise is unnecessary. We don't want to listen what unnecessary sound. We hear a lot of music. Why? Because we enjoy. We enter, enter we do entertainment. That's why. So whatever you are liking, whatever you like sound, so that will be music. That will be better for you. So musical sound, pleasant and regular vibration. Yes, it is produced by musical sound is produced by using instrument. Noise is what unpleasant. You will not get what pleasure, irregular vibration. It now noise can be observed in traffic place, and music sound it can be heard by playing instruments. Right. Next, noise pollution causes horns, loudspeaker, machinery, traffic. All these are reasons. That's why noise pollution increase, and it happens. Effects: hearing loss, stress, poor concentration. Yes, yes. Even if your home is near to the road, then you can observe what your concentration of your family would be less. Uh, if you are studying, then concentration of your would be less. Mm. you will be disturbed if your home is near to the road. Then control how can noise pollution be controlled? So by planting trees, by soundproofing, by limiting volume, noise pollution can be controlled. Okay. It is also duty of public, it is also duty of government, both will be responsible for this. Clear? Noise pollution can be solved. If it is a problem, yes, it is a problem. We observe, we observe. But problem is that nobody cares. Nobody cares. Some people, some people will care that here noise pollution is more, very more. But you can say 75% people of a area will not care about noise pollution, about water pollution, about air pollution. 75% of a area, 75% people of area will not care. That's why it is seen that mm, noise pollution is increasing in this area. Even it is not happening only in our country, it is also it happens also in another country. But we lives in our country, so here, rather than focusing on noise pollution of other country, we just need to focus on our country, what is happening in our surrounding area, whatever are problems which are being faced by people will solve, you can solve. Okay, so I am moving towards this side. Oh, we have some question. So let's see, what did we see, what did we explain? What produced sound? Yes, 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 vibration produces sound. Who produced vibration? Clear. And okay, what is the audible range of human hearing? So audible range is what? 20 hertz, and 20 hertz, from 20 hertz till the 20,000 hertz, it is the audible range of human hearing. I told you what will happen if we hear uh, amount of if we hear sound which amount is less than 20 hertz, then what will happen? uh, we will not be able to hear anything if amount of a sound is less than 20 hertz. Then now, okay, then what about 20,000 hertz? If we hear if we hear a sound which amount is more than 20,000 hertz, then what will happen? So here something will be, something not directly I would say, your ear will damage if you hear a sound which amount is more than 20 hertz, then your ear will damage. So you can think, you can understand what am I trying to tell. Just avoid that sound which amount is more than 20 hertz, 20,000 hertz. Just avoid that sound. Okay. What are the characteristics of a sound? Yes, we saw what amplitude. Amplitude determines what? Loudness. Frequency determines pitch. Pitch is low or high, it will be determined by frequency. Okay. What about time period? Time period will tell you, will explain that uh, how much wavelengths have passed within how much times. So uh, uh, you remember one wavelength will, no, Even one wavelength can move within a 2 seconds. Okay, leave it. Oh, wavelength. What about wavelength? Wavelength is a distance between two wave crust or two wave tuft of a wave. What is echo? When is it heard? Echo is a reflection of a sound, but this is a first reflected sound. So it is a first reflected sound. Echo is a first reflected sound, and it is heard when two objects are used to vibrate, and when it vibrates, then it travels and hits on the another object, on the third object. You can say then a reflection of a sound comes. We hear that reflected sound, which is a echo. What is the noise pollution and how can it be controlled? What is the noise pollution? How can it be controlled? So it is what unnecessary sound. It comes from traffic. It it is produced by vehicles, by horns. How can it be controlled? This is question. How can it be controlled? So it can be controlled by many methods, by many ways. Here, public will think what will be solution of uh, reducing noise pollution. So here, thinking of a human will be useful to reduce noise pollution. To reduce noise pollution. How can it be controlled? So I told you there are many ways. For instance, by planting trees, noise pollution can be reduced. If a volume is limited, then then it can be reduced. Clear? There are many ways. Now, what about next slide? So this is the end. Till here we are done.